React has changed a lot over the last 2 years. Not in the sense that the old React code you have won't work in the modern era, but there's kind of a whole new React paradigm that we can work with now. Server components fundamentally change how React works, so much so that you could fairly describe it as two Reacts. What do I mean by that? I know you guys are asking me, but I'm actually asking the same question to Dan Abramov, who wrote an awesome article we're going to go through today. Two Reacts by Dan. First and foremost, so good to see Dan writing again. I've always loved the Overreacted blog, and I am hyped. There's a new post. This one's been a long time coming. The two Reacts. Suppose I want to display something on your screen. Whether I want to display a web page like this blog post, or an interactive web app, or even a native app that you might download from some app store, at least two devices must be involved. Your device and mine. It starts with some code and data on my device. For example, I'm editing this blog post as a file on my laptop. If you see it on your screen, it must have already traveled from my device to yours. At some point, somewhere, my code and data turned into the HTML and JavaScript instructing your device to display this. So how does this relate to React? React is a UI programming paradigm that lets me break down what to display, such as a blog post, a sign-up form, or even a whole app, into independent pieces called components, and compose them like Lego blocks. I'll assume you already know and like components. Check out react.dev for an intro if somehow you don't. And by the way, quick plug for react.dev. It is so cool that the React docs are in the state they're in. Shout out to Rachel Neighbors, as well as Dan and everyone else who contributed. This is one of the best ways to learn, not just React. And in my opinion, it's the highest bar of modern education materials for learning anything in the programming world. I teared up the first time I read these docs. And I know that sounds silly, but just knowing how much better off the next generation of developers were and how many people would find success that might not have otherwise through the quality of these resources, it hit me really hard. Speaking of quality resources, let's continue this blog post. Components are code, and that code has to run somewhere. But wait, whose computer should they run on? Should they run on your computer or on mine? Let's make a case for each side. First, I'll argue the component should run on your computer. To be clear, you is the user in this case, not the developer, but the person who opened the application up. Here's a little counter button to demonstrate interactivity. Click it a few times. Everyone's favorite, the counter. Assuming the JavaScript code for this component has already loaded, the number will increase. Notice that it increases instantly on press. There is no delay. No need to wait for the server. No need to download any additional data. This is possible because the component's code is running on your computer, which we see here. Everyone's favorite, simple example. I love that he's using Tailwind now, even if it makes this have to scroll. It was really cool watching Dan learn Tailwind. That's a whole aside. Anyways, really nice simple component. I'm sure that not only have we all written this, we've also seen Copilot try to write it for us. Here, count is a piece of client state, a bit of information in your computer's memory that updates every time you press a button. I don't know how many times you're going to press that button, so I can't predict and prepare all of its possible outputs on my computer. The most I'll dare to prepare on my computer is the initial rendering output, which is you clicked 0 times, and send it as HTML. But from that point on, your computer had to take over running the code. You could argue that it's still not necessary to run this code on your computer. Maybe I could have it running on my server instead. When you press the button, your computer could ask my server for the next rendering output. Isn't that how websites worked before all of this client-side JavaScript stuff? Yeah, and I'm sure as he's about to touch on, it's not always great. I was just on GitHub yesterday, and when I pressed the thumbs up button, it took about 5 seconds to actually see the number increase and to light up the correct state, because I was waiting on the server to let the client know, yeah, we accepted that. Here you go. You need to run more code on the client in order to have a good experience for a lot of these types of things, and I'm excited for him to talk about it. Asking the server for a fresh UI works well when the user expects a little delay. For example, when clicking a link. When the user knows they're navigating to some different place in your app, they'll wait. However, any direct manipulation, such as dragging a slider, switching a tab, typing into a post composer, clicking a like button, swiping a card, hovering a menu, dragging a chart, and so on, would feel broken if it didn't reliably provide at least some instant feedback. If you want to see what these behaviors look like in action, you might notice below this video, there are a couple buttons you can click. One's a thumbs up button. If you click it as a test, you'll see that it responds almost immediately to show you that like state, even if the server hasn't picked up on the like yet. The subscribe button works the same way, so feel free to hammer that if you haven't already. We appreciate it a ton. Anyways. This principle isn't strictly technical. It's an intuition from the everyday life. For example, you wouldn't expect an elevator button to take you to the next floor in an instant. When you're pushing a door handle, you do expect it to follow your hand's movement directly, or it would feel stuck. In fact, even with an elevator button, you'd expect at least some instant feedback. It should yield to the pressure of your hand, and then it should light up to acknowledge that you pressed it. Again, similar to the like button below this video, even if the server takes some time to receive that like and actually process it, when you click it, it should show you that you clicked it immediately. Maybe even lie about what the backend state is, because it's optimistic. When you build a user interface, you need to be able to respond to at least some interactions with guaranteed low latency and with zero network round trips. You might have seen the React mental model being described as a sort of equation. UI is a function of state, or UI equals F state. I love this simplicity. It isn't that simple, but I do love it. This doesn't mean that your UI code has to literally be a single function taking state as an argument. It only means that the current state determines the UI. When the state changes, the UI needs to be recomputed. Since the state lives on your computer, the code to compute the UI, your components, must also run on your computer, or so the argument goes. Here's where things get interesting. Remember, we just spent all that time arguing why the code should run on the user's device. Now we're going to describe why it should run on the other computer, the developer's device, the server, whatever you want to call it. Next, I'll argue the opposite. The components should run on my computer. We'll call this the HTMX chapter. Here's a preview card for a different post from this blog. Post preview, slug equals a chain reaction. Here's the post, has 2,452 words. Cool. How does a component from this page know the number of words on that page? If you check the network tab, you'll see no extra requests. I'm not downloading that entire blog post from GitHub just to count the number of words on it. I'm not embedding the contents of that blog post on this page either. I'm not calling any APIs to count the words. And I sure did not count all those words by myself. So how does this component work? This looks interesting to me. We have a read file call. We have a matter call. If you're not familiar with matter, it's used to grab headers from Markdown. So if you have a little section before you start writing your Markdown that describes like a title, a date, those types of things, matter lets you rip them really quick. So here we grab the file content. We just read the file from file system using the name that we pass as a prop. We then grab the data and content by putting it through matter, which again will strip the data, metadata stuff from the top, as well as the Markdown page content below. And now we can take the content chunk, split it by space, filter out things that aren't valid, and then get the length through that. Really nice, simple way to get word count. And now we have a pretty simple section, has a header, has the title, which it ripped from data here, and it also has the word count, which it got via this compute. This is really cool code that you absolutely cannot run on a user's device because it needs to have access to the file system to read this file. And as he specifies here, this component runs on his computer. When I want to read a file, I read a file with fs.readFile. When I want to parse the Markdown header, I parse it with gray matter. When I want to count the words, I split its text and count them. There is nothing extra I need to do because my code runs right where the data is. This is going to be an important theme, I have a feeling. Suppose I want to list all the posts on my blog along with their word counts. That's easy. Here's the post list component, which does that, even scrolls. All I needed to do was to render a post preview for every post folder, which we see here. We have redirectory, post preview, then this async posts list reads all of the posts, grabs all the directories, and then renders all the previews. Nice, simple, readable. If you've already written JavaScript that runs on a server or in a CLI, you're familiar with all this code. Pretty cool you can do that in React now though, right? I think so. None of this code needed to run on your computer, and indeed it couldn't, because your computer doesn't have my files. Let's check when this code ran. That's actually a cool idea. By putting the new date.toString here, we get the point at which this code was run, which notably, it's not right now. Actually, is it? Let's refresh and see. I refreshed, and that is the time that this page was last built. My guess is that if he was to push an update to his website, this would update too because all the pages get rebuilt. But this is not code that is showing my current date time because it's not running on my computer. Oh, look, he even says the same thing. Aha, that's exactly when I last deployed my blog to my static web hosting. My components ran during the build process, so they had full access to my posts. Ooh, this part's in bold. He doesn't do that often. Running my components close to their data source lets them read their own data and pre-process it before sending any of that information to your device. Hopefully this is starting to click, but I have a feeling he's going to make the lesson even clearer as we go. By the time you loaded this page, there was no more post list, no more post preview, no file content, no DIRs, no FS, and certainly no gray matter. Instead, there was only a div with a few sections with A's and I's and the other tags you need to render inside of each of them. Your device only received the UI it actually needs to display, which in this case is the rendered post titles, the link URLs, and the post word counts, rather than the full raw data. I've talked about this in a few of my videos, specifically my airplane-proof website vid. There's a lot of things that used to scare me if they were done in React, because if you are passing a ton of big props, like a bunch of SVGs for background images that are part of your JavaScript code, that's now a giant bundle you have to send to your user. But if that only needs to be on the server, you can do a lot more with React without worrying about how it affects the size of the client bundle. And that's what he's touching on here. You can use the data from all the blog posts without having to send all the blog posts to the user. Previously, building something like this would have required making a separate API or data layer of some form to get the data those components need. That's not the case anymore, which is really cool. With this mental model, the UI is a function of server data, or UI equals F data. That data only exists on my device, so that's where the components should run, or so the argument goes, and so the HTMX people would push. But this new reality is somewhere between. Let's see how he frames it. UI is made up of components, but we argued for two very different visions. One is that UI is function of state, where state is client side and F runs on the client. This approach allows writing instantly interactive components like counter. Here, F may also run on the server to get the initial HTML. This is the traditional SSR we're used to from old Next.js page router stuff, from Gatsby, from Remix, from all these other solutions. Point 2 is where things get interesting though. UI equals F of data, where data is server side, and F runs on the server only. This approach allows writing data processing components like post preview. In that case, F runs categorically on the server only. Build time counts as server. I think it's an important distinction to make. This is why he said my computer and your computer throughout, because when people think of servers, they don't necessarily think of a build step. But the concept is that a computer that isn't the user's is the one generating this content, be it during build or on request via a server. If we set aside the familiarity bias, both of these approaches are compelling at what they do best. Unfortunately, these visions seem mutually incompatible. If we want to allow instant interactivity like needed by Counter, we have to run the components on the client. But components like Post Preview can't run on the client in principle because they use server-only APIs like read file. That's the whole point. Otherwise, we might as well run them on the client. Okay, what if we run all components on the server instead? But on the server, components like Counter can only render their initial state. The server doesn't know their current state, and passing the state between the server and the client is too slow, unless it's something tiny like the URL. And it's also not always possible. Like the blog only runs on deploy, so you can't pass stuff to it. Since this is generated via a build step, we can't tell after it's been built, hey, server, I want different content. You can give a different URL that leads to some different pre-generated content, but I couldn't click the counter and expect all of the different values to have already been built and sent to me. Again, it seems like we have to choose between two different Reacts. One is the client React, UI equals function of state, that lets you write the counter. And the other is the server, which is UI is a function of data, that lets you write post preview. But in practice, the real formula is closer to UI equals F of data, comma state. If you had no data or no state, it would generalize to those cases. But ideally, I prefer my programming paradigm to be able to handle both cases without having to pick another abstraction. And I know at least a few of you would like that too. The problem to solve then is how to split our F value across two very different programming environments. Is that even possible? Recall, we're not talking about some actual function called F here. F represents all our components. Is there some way we could split components between your computer and mine in a way that preserves what's great about React? Could we combine and nest components from two different environments? How would that work? How should that work? Give it some thought, and next time we'll compare our notes. What a goddamn cliffhanger to end on, Dan. I love it. Wow. What a post. I had high hopes, but this did a really good job of distilling the mindset of why the new component model is so powerful. If you're ready for that second part of what it would look like for these things to interop, I'll pin a video in the corner where I break down the new model and how it perfectly encapsulates the ideas that Dan was describing here, letting you meaningfully switch between server and client components when it makes the most sense for what you're building. This is a great post. Thank you so much, Dan, for writing it. See you guys in the next one. Peace, nerds.